Hi guys! Today's activity will be an Electrons and Circuits Lab. The question we'll be trying to answer is, why are electrons important in my daily life? Before you begin the lab, watch the following YouTube videos. The first video is especially important because it's a review of information that we did earlier this year that relates to the lab. A circuit is a complete closed loop in which electrons can travel. The materials that you'll need for this lab are aluminum foil, scissors, tape, a 9-volt battery, holiday lights, paper to tape the circuits on. First, cut some strips of aluminum foil to get ready for the lab. Obtain an old strand of Christmas lights. Take a pair of scissors and cut lights out of the strand, leaving about 2 inches after the light bulb on both sides. Take a pair of scissors and make an indent in the plastic wire. Twist the plastic off of the copper wire, and as you're twisting, pull away from the light bulb, and it should come off for you. First, you're going to create a simple circuit, including a battery, wire, which in our case will be the aluminum foil strips, and a light bulb. Tape down aluminum foil on your paper, leaving an opening for where the battery will be. Also tape down your light bulb onto the aluminum foil. It should be standing up. Put the battery down on the edges of the aluminum foil that you left open. This will close your circuit and allow electrons to flow in a complete circle. This will make the light bulb light up. Next, to make a bigger, simple circuit, I opened up my manila folder and made a giant one. While I was doing this lab, I noticed that my battery was starting to go dead and 1 or 2 of my lights were burnt out. So just keep an eye out for that. You might be doing everything right, but maybe your materials are not working for you. The next thing you'll do is you'll make a series circuit. A series circuit will include 3 light bulbs in one continuous loop. So there's going to be one pathway for electrons to go from the battery through each light bulb and then back to the battery. Make a series circuit with 2 bulbs. So it's going to look like this, and it's going to be open because you don't have your battery connecting the aluminum foil yet. Close your circuit, see your light bulbs light. Next, make a series circuit with 3 light bulbs. Same idea. What do you think will happen if a bulb is out or missing in a series circuit? It looks like we have the battery here, but it's not lighting up. Now we're going to move from series circuits to parallel circuits. Look at the 2 schematic diagrams on this slide and think to yourself, what's different about them? In the series circuit, electrons will move from the battery and they have to go through every light bulb in order to travel back to the battery. In a parallel circuit, here's the battery. Electrons can travel through this pathway and go through this light bulb. Electrons can travel through another pathway and go through this light bulb. Or electrons could travel through one final pathway and go to the third light bulb and back to the battery. So we're going to make another simple circuit. For this one, I made a smaller rectangular circuit and left it open. As you can see there, there's no battery connecting the two sides of the aluminum foil. Put the battery on and make sure that the first light will work when it's closed. Now, we're going to create a parallel circuit with two bulbs. So you're going to set it up like this. Put your battery on the edges of the aluminum foil to complete the circuit. Now make a parallel circuit with three bulbs. Close your circuit. What do you think will happen if a bulb is out or missing in a parallel circuit? Ah, they are still lighting up, even though a bulb is missing. Next, you're going to test out which materials will close the circuit. So I just used my original circuit, and I have the battery connecting aluminum foil here. I have a light bulb, and then I left a break in the circuit up here. So what you can do is you can take different materials and see if they will close the circuit and allow electrons to flow from the battery through the light bulb, through the material, and back to the battery, and continue to do so. So as you can see here, the metal part of my scissors did complete the circuit, which means that that metal is a good conductor. It will allow electrons to flow. Now, the next thing I tried was a Sharpie marker, which has a plastic outside. The light bulb is not lighting, so that means that that plastic is an insulator. So plastic will not allow electrons to easily flow through it. So the circuit is still open at that point. I tried a pencil, no go. I tried a fork. That worked. Come up with creative ideas to try to see whether or not those materials are conductors or insulators. The wrap-up activity for today is create a Padlet post. Everyone needs to answer number 1, which is, how did the lab go for you today? What did you think of it? Then you can choose to answer one of the two prompts for number 2. Either type a list of 3 different items or materials that you tested and identify them as conductors or insulators, or take a picture of your conductor or insulator circuit with a test item, like my example photos.